Alright, so we are looking at the pattern of the day. This is Monday, January 11th, 2021. And this is lesson 5.5. Alright, see if you can determine the next numbers. And if you can tell me the rule. Alright, Charlie, what number will come next? What number? What? You can do it on the bottom of page 105 in your notebook. You can do it in your head. You can do it on a piece of scratch paper. That will go in your red binder. If you want to wait, you can hole punch it later. All right, Charlie, do you know the next number?
75.
Not 75. Do you know the rule?
Goes up by 5 and then 10.
Well, if I start from 1, it goes up by what?
It goes up by 5 and then 10.
Where does it go up by 5? You're close, but not quite there. All right, Jenny, what's the next number?
65.
All right, the next number is 65.
I also know the rule.
Okay, hang on. All right, Jada, what's the next number?
60.
All right, Jalea, what comes next? What? Not 75. All right, let's look at the rule. All right, Jenny, tell me the rule.
Go up 10.
So I go up 10, and then what do I do, Zanaya? I subtract what?
2 or 5.
Well, you tell me. How much?
2.
Did I subtract 10 to get from 45 to 40?
I subtract 5.
I'm subtracting 5. So I add 10,
Then you subtract
and I subtract 5. I add 10, and I subtract 5. I add 10, and I subtract 5. All right? So my next number will be what? Not 75, but because let's see, this is the add 10. Here's the subtract 5. So I'll add 10. Helena, if I add 10, what do I have? Now if I add 10 to 60, 60 plus 10 is 60 plus 10 is 70. All right, good job. All right, so today we are talking about prime and composite numbers. Now we've already talked about prime and composite numbers, right? So you can tell me what a prime number is. What is a prime number? Zanaya? A number that only has 2 factors. 1 and the number. So a composite number has what? Jeremiah? What does a composite number have? More than 2 factors. So prime numbers only have 2 factors. Composite numbers have more than 2 factors. All right. This is where my rules of divisibility can help me go fast. So, open your little math books to page P105. P105, 105, 105. It's less than 5.5 at the top. All right. So I want you to see how I'm going to use the rules of divisibility. One way to determine whether a number is prime or composite is to do the factor rainbow for every number. But you guys should know your rules of divisibility, so you can use those. Because all I need to know is if it follows one rule, right? If it is divisible by one other number. So if it matches the rule for 2, 3, 5, 6, 9, any of those rules, if it matches any of those rules, then it's what? Is it prime or composite? What is it, Jeremiah? It's composite because I know that there's 1 in the factor and whatever that number is and the factor. It doesn't ask me to list all of the factors. It just wants to know if this is prime or composite. So, for example, I look at 47. And when I look, right, if you need them, you can get out your divisibility rules and you can go through those divisibility rules. All right, so when I look at 47, I go through my divisibility rules. Is this number divisible by 2? Okay, no, because it is not even, so that's a no. Is it divisible by, wait. What? Yes, it's divisible by 3? But I'm looking at 47. Well, is 47 divisible by 2? And the answer was no, because it's not even. Okay? Now, then I decided I was going to wait and let everybody get their divisibility rule sheet out. All right, now, I look at the rule for 3. I add the digits together. 4 plus 7 is 11. Is 11 a multiple of 3? No. So it is. 47 is not divisible by 3. Is 47 divisible by 5? It is not. Is 47 divisible by 6? It is not, because it's not divisible by 2 or 3. All right. Is 47 divisible by 9? No, I add the digits together, 7 plus 4, I get 11. 11 is not a multiple of 9. So, it's not divisible by any of those numbers. It's prime. All right? Let's go to the next one. 68. Is 68 divisible by 2? Yes, it is an even number. Do I have to go any further? I do not, because I know that 68 is what? Prime or composite?
Composite.
It's composite. All right, let's look at 52. I start with my divisibility rules, and I start with 2. Is 52 divisible by 2? Yes, it is, because it's even. So is 52 prime or composite? All right. All right, next I'm looking at 63. I'm going to start with my divisibility rules. Is 63 divisible by 2?
No.
It is not, because it's an odd number. All right, is 63 divisible by 3?
Yes.
It is, because when I add 6 plus 3, I get 9, and 9 is a multiple of 3. So, is 63 prime or composite? It is composite. I don't have to go on any further. All right, 75. Is 75 divisible by 2?
No.
Is 75 divisible by 3? What do I do to determine if it's divisible by 3? Add the digits together. 7 plus 5 is 12. Is 12 a multiple of 3? It is. So 75 is composite. I keep throwing out this word multiple. What is a multiple?
It's when all of your have all the numbers.
Well, yes, but in this case, in this context, when I use the word multiples, the multiples of a number are what? Jaden? They're the products you get when you multiply it. So when I say, is 12 a multiple of 3, that means that when I multiply 3 times a number, I get 12 as my answer. All right. 31. Is 31 divisible by 2? I need everybody to give me an answer. You shake your head, yes or no? Okay. It's not. It's an odd number. All right, is 31 divisible by 3?
Yes.
All right, so my rule says that I add the digits together, so I add 3 plus 1 and I get 4. Is 4 a multiple of 3?
No.
Remember that I add the digits together, so I add all the digits, 3 plus 1 together, and I get 4. Is 4 a multiple of 3?
No.
It is not. All right, let's see. So I did 2 is no, 3 is no. What about 5? No, because that's not a 0 or a 5. What about 6?
If 2 or 3 was no, remaining 6 is
You are correct. What about 9?
no.
No. Here's a hint for 9. If 3 is no, then 9 is no. If 3 is yes, 9 may or may not be yes, but if 3 is no, 9 is definitely no. So, 31 is what?
Prime.
It's a prime number. All right, 77. And this one's going to break a little bit of our procedure, but I bet you guys can figure it out. All right, so let's do our divisibility rules. Is 77 divisible by 2?
No.
Is 77 divisible by 3?
No.
It's not. 7 plus 7 is 14, and 14 is not a multiple of 3. 77 divisible by 5?
No.
Is 77 divisible by 6?
No.
Is 77 divisible by 9?
No.
Is 77 prime?
No.
You are correct. 7 times 11. So 77 is not prime. It just doesn't meet any of our divisibility rules. So it is a composite number. All right, 59. Is 59 divisible by 2? Thumbs up for yes, thumbs down for no. Show me. Is 59 divisible by 2? This last digit has to be a 0, a 2, a 4, a 6, or an 8. Okay, it is not. Is 59 divisible by 3? It is not. Is 59 divisible by 5? It is not. Is 59 divisible by 6? All right, it is not. Is 59 divisible by 9? No. All right, and then I'm going to check 7. And the way that I'm going to check 7 is I'm going to say, okay, 7 times 8 is 56. 7 times 9 is 63. So 59 is not. So 59 is what? It is a prime number. What? I can't hear you. What? You what? Okay, well, do you need to go see Miss Freeman? Okay, go ahead. All right, let's look at 87. Is 87 divisible by 2? Cody, is 87 divisible by 2? It is not. It is not an even number. Good. All right, sit up. Okay. All right. Is 87 divisible by 3? Okay, how do I go through the process? So talk me through the process. I add 8 plus 7. What do I get when I add 8 plus 7? 15. Is 15 a multiple of 3?
Oh, yeah.
Yes. Yeah. 3, 6, 9, 12, 15. Remember, multiples are the numbers I get when I multiply. All right. So 87, is it prime or composite? It is composite. All right, 72. Is 72 divisible by 2? It is. So 72 is what? Is it prime or composite? All right. 48 49. If I know my multiplication tables, this one's real easy, but otherwise I have to... 7 times 7 is 49. So, no, what is 49? Is it prime or composite? It is composite. All right, 73. All right, let's go through my divisibility rules. Is 73 divisible by 2? It is not. Is 73 divisible by 3? What do I do to determine if it's divisible by 3? I add 7 plus 3. When I add 7 plus 3, I get 10. When I count by 3s, do I ever say the number 10? Nope. 73 is not divisible by 3. All right, is 73 divisible by 5? Nope. Is 73 divisible by 6? Is 73 divisible by 9? All right, so in all likelihood, is 73 prime or composite? It is prime. All right, Kai wrote the number 85 on the board. Is 85 prime or composite? It is composite. Why? Okay, it's composite because it has more than 2 factors. And it's 5. And I checked with 5. So I'm going to say that I checked with 5. That means I know that 5 is a factor of 85. Why do I know that? Well, I know that if the number ends in a 5 or a 0, it's divisible by 5. All right, Lisa says that 43 is a 2-digit odd number that is composite. Is she correct? Well, do I need to go through and check? Is 43, well, it already says it's odd, so 43 is not divisible by 2. Is 43 divisible by 3?
No.
No. 3 plus 4 is 7. So that won't work. All right, what about 5?
Nope.
What about 6? Nope, because 2 is not, and 3 is not, so 6 is not. What about 9? Nope. All right. So 43, so is she correct? Okay. Is she correct? No. 43 is prime. It only has how many factors? 2 factors. 1 and 43. All right. All right, look at number 2. I'm going to give you a rule breaker. Well, it's not really a rule breaker, it's a rule. When I look at the number 1, 1 is neither prime nor composite. So the number 1 is neither prime nor composite. All right, I would like you to complete number 1, 3, 4, 5, and 6. I would like you to go ahead and finish page 106.